Assalamu alaikum. One more problem from the I don't remember. I think this is from practice questions, question number 7. It's given that a 275 kV transmission line has the following line constants. A is given as this, B is given as this. Okay. Determine the power at unity power factor that can be received if the voltage profile at each end is to be maintained at 275 kV. This is one part. So in this case, we need to find out how much power is transferred or received at the receiving end if voltage at both the sides is 250 275 kV and the power factor at the receiving end is unity. What type of rating of compensating equipment would be required if the load is 150 megawatt at unity power factor with same voltage profile as part 1? So in this case, the power is given to be 150 and the voltage are again maintained at 275 kV and the power factor at unity. So we need to find out for this purpose compensating network, what type of compensation we need to require and how much rating of that compensation equipment should have to meet this type of requirement. And in the third case, with the load in part B, that means with the load in 150 megawatt, what would be the receiving end voltage if the compensating equipment is not installed? If we will not install the compensating equipment, then we need to find out the receiving voltage. Where will it go? Will it increase or will it decrease? So since A and B are given, so a transmission system given in this way, like this is a transmission network. This is is, this is VS, this is IR, this is VR. And in this type, since we don't know this, what is inside, whether it is short transmission line, long transmission line, or medium transmission line, we simply represent them by ABCD parameters. When ABCD parameters are given, then the power at this, that's PR and QR, the power at receiving end, sending in, power at receiving end and reactive power at receiving end, not this real power at sending end and reactive power at sending end. We're only concerned with the real and reactive power at the receiving end. It is given in terms of this: PR is equal to magnitude of Vs, magnitude of VR divided by B, this B which is here given, its magnitude, multiplied by cos of beta minus delta, where beta is the angle of B, that is this, in this case it is 75. Delta is the angle between Vs and Vr, that is the power angle which I have told you just before, minus A by B magnitude, magnitude of A by B, into Vr square, magnitude of Vr square, cos of beta minus alpha. Beta is the angle of B and alpha is the angle of A. This is in terms of alpha and beta. Similarly, QR is equal to Vs Vr by beta sine of beta minus delta minus A by B Vr square sine of beta minus alpha. Now for short transmission line, because I will let you know just a few minutes more, after a few minutes, that we are always try to find out the real power, reactive power in terms of short transmission line. That's why I will write it down in terms of short transmission line as well. This is a short transmission line. This is R, this is X. It is Z will be equal to magnitude of Z, R square plus X square, and theta, that is the impedance angle, will be equal to tan inverse of X by R. So in this case, PR and QR will given by like this. That is magnitude of Vs, magnitude of Vr divided by Z, magnitude of Z, cos of theta minus delta, minus Vr square divided by magnitude of Z, cos of theta. And QR will be equal to Vr, Vs Vr by Z, all the magnitude, sine of theta minus delta, minus Vr square by Z, sine of theta. So for lossless line, when R is equal to 0, you will see that Z will be equal to X, because this R will be 0, Z will be equal to X, and theta will be equal to 90, tan inverse of infinity. When R is equal to 0, tan infinity will be 90. So these equations will reduce to, because when theta is equal to 90, cos theta is 0, and cos theta minus delta will be equal to sin delta. So it will be equal to Vs Vr by X, sine of delta, and QR will be equal to Vs Vr by X, cos of delta, because sine of 90 minus delta will be cos of delta, and Vr, this sine 90 will be equal to 1, it will remain as it is. So these are the equations for the short transmission line, lossless short transmission line of this type. We'll be always using these two equations apart from this question mostly. That's why I derived it here for you. You might have done it on your own, but still I did it here. Now coming to the question where we have to use the first formula that I have told you in terms of ABCD parameters. Now Vs is equal to Vr is equal to 75 kV, alpha is equal to 5 degree, beta is equal to 75 degree. Power factor is unity means phi, that is the power factor angle, is equal to 0. That means QR is equal to root 3 VR IR sine of phi, which will be equal to 0. By using this equation, just now which I have told you, that QR is equal to Vs VR by B sine of beta minus delta minus A by B VR square sine of beta minus. Just a minute. Actually, we are asked to find out the determine the power. Determine the power. When we use this equation, you can see it from here. When we use this equation, Vs is given, Vr is given, beta is given, this beta is given, delta is not given, A is given, B is given, Vr is given, this beta is given, and alpha is given. So in this equation, it is only delta which is unknown. So to calculate this PR, we need to find out first this delta. That can be um, calculate from this equation, because in this equation also all the quantities are known, that is this Vr Vs beta, this beta A B Vr beta alpha, and Qr is also known, which we just calculate equal to 0. So from this equation we will first calculate delta, that's here. This is Vr square, Vs into Vr, since the value are same here, it will be 275 square divided by 200, that's the magnitude of beta. It's given as 200 angle of 75, so we have to use only this magnitude. Sine of 75 minus delta minus 0.85, that is B, sorry, A divided by 200 into 275 square sine of 75 minus 5, this is beta minus alpha. So upon simplification, this is actually the value of this term, 275 square divided by this, it will go to 378.125, and this 302 is the value of this whole term. So because in this case this term is all known, so by following the simple steps we can calculate this value, delta. It comes out to be equal to 22 degrees. So when delta is equal to 22 degrees, we can put this value into the PR formula and get the value of this PR. It comes out to be 117.63 megawatt. This is simply putting the different values, because now we know the value of delta, we just other values we already know, so we calculate the value of delta. In the second case, the power demand has increased. This is the power demand, 117 megawatts. Now power demand has to be increased to 150 megawatt, and we need to calculate the value of what? The value of reactive power first. From this, since again for reactive power, you can see Vs is given, Vr is given. In this case also voltage profile has to be same. That means Vs is equal to Vr is equal to 275. This is given. Beta is given. This A is given. B is given. Vr is given. Beta alpha. In this case also this delta is unknown. This delta can be found from this equation, because in this case PR is given to be 150 megawatt. While putting the value of this 150 megawatt like this, we can get 150 is equal to this minus 110. This is the second term which is completely known. From this we can calculate delta equal to 28.46. Now we can get the value of QR. QR is equal to 75 square divided by 200 sine of this minus this. From this QR is equal to 27.56 MVAR. So minus here, because since Vs is equal to Vr, we just in the first numerical we just calculate that VSVR means voltage regulation 0 when the power factor is leading. When the power factor is leading, and when the power factor is leading, you will see that QR will always be negative. Negative means it is actually, it is not consuming the reactive power, it is supplying back to the reactive power. Now one more condition that is to be fulfilled is that power factor should be unity. For power factor should be unity, that QD should be equal to 0. That means the supplying back of the reactive power has to be consumed locally, so that the power factor seen, or we can say the reactive power supplied from this supplying should be equal to 0. So this is the condition without using a compensating network. From the transmission line or from the supply side, we are receiving PR and QR like this. PR is 150 and QR is minus 27.56. It should be J times, just to indicate the imaginary part, and this also same power is received by the load. But what we do, we use a compensating part which consumes this uh, 27.56. You can just see that when we add these two, it will be 150 minus 27.56 minus plus 27.56, so that this QD is equal to 0. The power now supplied will be only real power, and we can say that real power factor is unity. Or you can get it from here also, since QD should be equal to 0, which is equal to from here, by simply using the KCL over here, this QD should be 0, and it is equal to QR plus QC, that is equal to 0. From this we can calculate QC is equal to plus 27.56 MVAR. So here we have to supply, we have to connect uh, compensating network at the receiving end, and whose value should be equal to 27.56 to make the power factor unity and to make the voltage profile same as 275 kilovolt. Now the third part is that if we don't use, that means this type of system, if we don't use this compensating part, what will happen to the receiving end voltage? Because in that case receiving end voltage will suffer. You can see it from here. Now PR is 150 and QR has to be equal to 0. QR has to be equal to 0, so that this VR will see how much will be its value. It will be equal to, again we will calculate this from the delta from this. We'll use two equations, and then by simply substitution from one and another we can calculate VR. Just the equation I just I have to show you on the calculator like this for question in which we have two variables and two equations. We can substitute one equation to another to get the required variable. From here these two are known, PR and QR are known. I will put it over here. It is 150 is equal to 275 by 200 into VR cos of 75 minus delta minus 0.83 by 200 cos of 70 into VR square. In this you will see that there are two variables, delta and VR. Similarly 0 is equal to, because QR is equal to 0, 275 into VR by 200 sine of 75 minus delta minus 0.83 by 200 sine of 70 into VR square. So in this equation, we can simply VR and VR will cancel out, because there are two VRs, VR square and VR, it will be cancel out, and this whole term is known, and I will divide it by this term. You will get sine 75 minus delta is equal to 0.0029 VR, and from this equation, because sine theta is equal to square root of 1 minus cos square theta, cos theta is equal to square root of 1 minus sine square theta. I will use this equation. So cos of 75 minus delta is equal to 1 minus this sine theta, sine square, that means 0.0029 VR square whole raised by 1 by 2. And then it is to be solved just I showed you before, and this VR comes out to be equal to 244.9. It is definitely less than 275 kV. So in this case, if we don't use the compensating network, our voltage will be dropped. I hope you understood this.